Okay, example 7. So this one's a little bit tricky. It says, firm ABC has a risk-free investment opportunity with an initial investment of $120,000 today and a cash flow of $150,000 in 1 year. For what level of risk-free interest rates is this project attractive? In other words, what does the market risk-free interest rate have to be for the ABC to be a good investment? Okay, so the situation is there's already a risk-free investment opportunity in the market. Let's say the U.S. government bond. Okay, so the rate of return offered by the U.S. government bond is the market risk-free interest rate. Okay, and then ABC is coming into the market with its own investment opportunity. They're saying, if you give us $120,000 right now, we'll give you $150,000 in a year risk-free. Okay. So there are two ways to think about this. First, ABC's project is only worth investing in if it has a positive NPV. Okay, so we're gonna look at the cash flows promised by ABC and then calculate the NPV to see if it's greater than 0. Okay. The second approach is the project is only worth investing in if it yields a better return than other alternative opportunities. That is, the return offered by ABC has to be greater than the market risk-free rate for it to be a good opportunity. Okay, so we're gonna do these two ways. So, example 7. Okay. So again, the situation is we're trying to evaluate whether ABC is a good investment. Is ABC a good investment? That is, we're going to compare the ABC's investment against what already exists in the market. Okay, so basically risk-free investment in the market versus ABC opportunity, or rather opportunity offered by ABC. Okay, so this is something like the U.S. government bond. Okay, so we'll do the first method first. Okay, so good projects have a positive NPV. Okay, so the return offered by the risk-free investment in the market, we'll call this RF. Okay, just it's a market risk-free rate. Okay, let's first draw the timeline of ABC's investment. Okay. So here, ABC is saying if you give them $120,000 right now, they'll pay you $150,000 in 1 year. Okay, and they're saying it's guaranteed. Okay, so what we're gonna do is first we're gonna figure out the NPV of this project. NPV. Okay, so the net present value is basically converting all of these cash flows into time $0, right? So I'll just say the cash flow that occurs in time 0 is already in time 0, and then we're gonna take the present value of the cash flow that occurs in year 1. Okay, so to make it more clear, I'll highlight these cash flows. So this 120,000 is the cash flow that occurs in year 1 or year 0. Okay? And this 150,000 is the cash flow that occurs in year 1. Okay? So again, getting the NPV at time 0 is basically converting all of the cash flows back to time $0 and then adding them up. Okay? So this is the same thing as cash flow 0 plus cash flow 1 over 1 plus RF to the first power. Okay? So this has to be greater than 0 for ABC's investment to be a good investment opportunity. Okay? So this formula is the PV formula. Okay? That is, we had this formula before, right? Yeah. So since the green cash flow occurs in year 1, it's a future value, right? We're trying to convert that to time 0, and the way you do that is applying this PV formula, where R is the risk-free rate, because this is a risk-free investment opportunity, and N is 1 because it occurs in year 1. Okay? So if we put the numbers in, then MPV is negative 120,000 plus 150,000 divided by 1 plus RF to the first power. This has to be greater than 0 for NPV's or ABC's project to be a positive NPV project. Okay. So that's the cash flow that occurs in year 0. 150,000 is the cash flow that occurs in time 1. Okay. So yeah, what the problem asked was, what does the market risk-free interest rate have to be for the ABC to be a good investment? Okay. So this is the expression. We want the NPV of ABC to be greater than 0, then it's a good investment. Okay. So at this point, we're basically done, but we want to get the RF by itself. So this expression in the red box is the condition where ABC's opportunity is actually a good opportunity. Now the next step is to solve for RF. We want to make an expression so that RF is by itself. Okay, so the rest is algebra. So I'll show you the algebra. Okay, so we're starting with this expression. If this condition is true, then ABC is a good project. Okay, so we're trying to get RF by itself. So first, I'm gonna add 120,000 on both sides of the expression. So basically, it becomes 150,000 over 1 plus RF to the first power, but that doesn't really mean much, right? So the right hand side is now 120,000. Okay, so at this point we want RF by itself, so we don't want the parentheses that contains the RF on the denominator. Okay, so to address that issue, I'll multiply both sides by 1 plus RF. So this side, these will cancel out. Okay, 150,000 greater than 120,000 times 1 plus RF. Okay? Raise to the first power, and we'll divide by 120,000 on both sides. Then we have 150,000 over 120,000. That is greater than 1 plus RF. In the last step, we're going to deduct both sides by 1, okay, to get RF by itself. Then we have 150,000 over 120,000 minus 1 greater than RF. Okay? And if you work out the math, it is 0.25 greater than RF. Okay? So, if the risk-free rate in the market is greater than 25%, then ABC's opportunity is a good investment opportunity. Okay? So again, this box right here is the condition where the ABC's project is a good investment opportunity, and we just reduce this down into this form, okay, by doing algebra to get RF by itself. Okay? Okay. And we'll do it the second way. Second way is a little bit easier. Okay? So here, still doing example 7. And we're still comparing the two opportunities. The risk-free opportunity in the market, opportunity in the market versus ABC's risk-free opportunity. Risk-free. But this time, instead of calculating the NPV, we're just going to look at the rates of returns directly and then compare them. Okay? So the risk-free rate in the market will still denote as RF. And the rate of return offered by ABC we'll say is RABC. Okay? So ABC's project is better only if the rate of return offered by ABC is greater than what's being offered in the market. Okay? So this is the expression that we're starting with this time. Okay? So I'm going to draw the timeline again. ABC's project. If you pay $120,000 now, you'll get $150,000 in 1 year. Okay? So here we can directly use the rate formula. The rate formula was future value divided by present value over, or raised to the 1 over nth power minus 1. Okay. So here, this amount, we're going to convert this into a positive value. It's just how the formula works. So we'll treat this as the PV. This $150,000 becomes the future value, and 1 is the N, how long the investment period is, and then we can figure out the R, right? So the rate offered by ABC is 150,000, and make sure you put in the positive number here, 120,000 as the PV, and then it's 1 over n, which is 1, so it's just raised to the first power. And if you do the math, you'll see that this is 0.25. Okay? So this value Now we're going to put it back in here. Now we know what our ABC is. Okay? So the final answer is still the same. ABC's opportunity is more attractive compared to what's already being offered in the market if this condition holds true. Okay? Notice that we have the same answer as before.